So the learning target today is determining end behavior of a function without graphing. In order to do this, the first thing I'm going to do is to put my function in standard or general form. That is, I want to have the term with the highest exponent first and proceeding on downward until we get to our constant. Once I do that, I'm going to find the highest exponent and determine whether that exponent is an even or an odd number. Then I'm going to look at A, which is also called the leading or lead coefficient. Is that number positive or negative? And last but not least, then I just have to write the end behavior. But sometimes I really like to look at it in a chart form, so figuring out what really are my choices. This will help you determine the only 4 choices you have. Once you have it in standard form, so step 1, you determine whether you have an even or an odd function. Remember, even and odd is the highest exponent. If the highest exponent is even, you have an even function. If the highest exponent is odd, you have an odd function. And don't forget that linear functions have an exponent of 1, therefore they are an odd function. Once I get here, though, I have to ask myself a second question. The second question is my lead coefficient, my A, is it positive or negative? Same question here. Is the lead coefficient positive or negative? So working within the even functions, that is x squared, x to the 4th, x to the 100th, whatever it is, if I have a positive A, I know that both ends will go up. That is, a parabola with something that had f of x equals 2x squared would be both up. So this might be f of x equals 2x squared. And I know this is even, that's what puts me in this column. And I know this is positive, that's what tells me both go up. Now, if I had a negative A, that is f of x equaling negative 5x squared, this is still an even exponent, so it's an even function. However, this is a negative 5, so the lead coefficient is negative, which just means both go down. Now, working with odd functions, we could see something, if I have an odd function, I still have to look at the A. And again, the linear helps people really think about this, because we all know when we have a negative slope or a negative lead coefficient, that we have a negative sloping line, and it points down like that. Versus if I have a positive A, my line's going to look like this. So if I have a positive A and my line is pointed up to the right, I'm simply going to put the left end goes down and the right end goes up. If I have a negative slope, I'm going to have something like this, where the right end is going down and the left end is going up. So I have left up and right down. Some examples of these functions might be f of x equals x plus 7. We know there's a little invisible 1 there. That makes it an odd function. We know there's a lead coefficient of 1. That makes it a positive number. Therefore, left down, right up. If I had a negative A, it might look like f of x equals negative 4x cubed. The cube is odd, so that becomes an odd function. The negative 4 is my lead coefficient. It's a negative number. Left up, right down. And that's how you determine end behavior.